In this lesson, we shall focus on the limit of the square root function. We are actually focusing on the limit of the square root of x as x tends to 4, and we're told that the limit is 2, and we need to actually proceed to give an epsilon delta proof. So an epsilon delta proof is required. And so to actually prove this, we let f at x be equal to the square root of x, right, be equal to the square root of x that way. And so what then do we do then at this point for every, right, for every epsilon positive there can be found a delta positive such that for all x that are elements of the domain of f, if 0 is smaller than x minus 4 is less than delta, then the absolute value of the square root of x minus 2 is smaller than epsilon. And so at this point, we take a look at this and we note, therefore, that we can proceed to then say, now we shall focus on this part. The absolute value of the square root of x minus 2 can be written as the following, yeah? Can be written as the following. So it can be written as minus 2 plus the square root of x. And then you multiply by minus 2 minus the square root of x minus 2 minus the square root of x. Minus 2 is actually a 4 minus the square root of x. Minus 2 minus the square root of x. Which is x minus 4 all divided by the square root of x plus 2. Exactly this way. Exactly this way. And so now when you have this, we continue to analyze this at this point, because what we have is that the absolute value of the square root of x minus 2 is exactly the same as x minus 4 all divided by the square root of x plus 2. Okay, so you have this exactly. You have this exactly. And so this actually can be broken down into two pieces. You have this all divided by x plus 2. X plus 2. And so what then do we need out of this? What then do we need out of this? So we actually take note of the fact that this is actually exactly less than x minus the modulus over x minus 4, the magnitude of x minus 4. You see, this is true, obviously, since the absolute value, or 1 over the absolute value of x plus 2 is smaller than 1 as x tends to 4. Okay, as x tends to 4, this is smaller than 1 because, for instance, at any number, it is always smaller than 1. Okay, at most, for instance, at 4, you have 2 plus 2, which is 1/4 smaller than 4. Okay, so we have that exactly. We precisely have these. Thus, we can say that whenever we have the absolute value of this here is the absolute value of the square root of x minus 2, which is smaller than x minus 4. Okay, so you have this, and this is smaller than, we know that the absolute value of x minus 4 is smaller than epsilon. It is smaller than epsilon. Right. And so we have that. However, we look at this and think about it, but think about it extra carefully and actually analyze what all this means. But this gives us a single value of delta. So we get that delta is epsilon here. You get that delta is epsilon. However, in view of the domain of this function, because this function here, the square root of x, has a domain restriction associated with it. It doesn't have the overall real line as its domain, etc., or the entire complex plane as its domain. It has some domain restrictions, at least within the realms and the ambits of real analysis. And so now what we then need to do is to actually say that since we know that 0 is smaller than x minus 4 is smaller than delta, this is minus delta is smaller than x minus 4 is less than delta. Can write it like that. And so what we then need to do, we need to simplify these to an x. And so we add 4. So we're 4 minus delta. We add 4, it becomes only x, and we add 4 also to this here. We also add 4 to this here. We add 4 to this here. Okay, so the domain restriction on the square root of x is very clear. It's very clear that we require that the x be greater or equal to 0. So in other words, this x must be greater or equal to a 0. And so we require, therefore, that, okay, we can always say that in writing. Right, so I want us to take this statement into account and say, if we have this, so in other words, we have 4 minus delta is less than x, which is less than delta plus 4. That is what we have from the previous step, from this step here. Okay, this is what we have. But with these then, the domain restriction of the square root of x is that x must be greater or equal to 0. And therefore, it means something that we require, right? We require that. Right, we require that, right, 4 minus delta be greater or equal to 0. And so when we do, because these x must be greater at least or equal to 0 for the absolute value to make sense. And so this implies that at this pointer, we can move the delta to the other side, meaning delta is less or equal to 4. meaning delta is less or equal to 4. So we have delta is less or equal to 4, but also we have that delta is associated with epsilon at this point. So we have star. And also we have this one we can call double asterisk. Hence, from star and double star, we have that delta equals the minimum. Delta equals the minimum. All right, so delta equals the minimum of what? Of the two things. Here, delta therefore is associated with 4, and on the other side, epsilon as well. And so we have that delta is the minimum of 4 and epsilon. And so this here is the result that is necessary for us to take into account. So we have got a delta that is 4, or the minimum of 4 and epsilon. And so we have solved this particular question step by step. And there are many other ways to, of course, solve this problem here. And one can proceed to solve it in many ways and get answers that perhaps look different but are very equivalent to each other. Right. So, but we must thank you for your attention. Right, as we have solved this particular question. Until next time, take care and goodbye to you.